So in the previous measurements, the bottom curve is important. Notice that a value of VGS of around -4 volts reduces the drain current to almost 0. This voltage is called the gate source cutoff voltage and is symbolized by VGS off on the data sheets. At this cutoff voltage, the depletion layer touches each other. In effect, the conducting channel disappears. This is why the drain current is approximately 0. We notice that normally for VGS cutoff equal to -4 volt and Vp is also equal to 4 volt. Vp is the pinch off voltage, we call it as a pinch off voltage, and which refers to the voltage where the drain current starts saturating. Now this is not a coincidence that VGS and Vp are equal to 4 volts. The two voltage always have the same magnitude because they are the value where the depletion layers touch or almost touch. Data sheets may list either quantity and you are expected to know that the other has the same magnitude. So as an equation, we say VGS off is equal to minus Vp. Now the transconductance or the transfer characteristic that we have measured is plotted as ID versus VGS. Notice the curve is non-linear because the current increases faster when VGS approaches 0. Now here, after plotting all the kinds of the characteristics, we have to see the significance of this. As we have seen that this is a voltage amplifier or a transfer because the input negative voltage or the reverse voltage is going to drive the final output current, and so this device is very effectively used where the input impedance is very large. For most linear applications, the bipolar transistor is preferred device. However, the unipolar transistor, that is FET, is much useful where the input impedance is expected to be very high. The typical JFET has an input resistance in the hundreds of mega ohms. This is the big advantage that JFET has over the bipolar transistor, and it is the reason that JFET excel in application in which a high input impedance is required. One of the most important applications of JFET is the source follower, a circuit in bipolar transistor called as emitter follower, except that the input impedance is in the hundreds of mega ohms for lower frequencies. So one should actually understand that apart from junction FET, there is another device which is quite important and mostly which is used is MOSFET. And MOSFET deals with metal oxide semiconductor FET, and there you will find that the input impedance is much larger, and that is usually preferred in the integrated circuits. Now, as far as your instrumental details are concerned, the instrument that you are using is not complicated. You are using a power source, DC power source, which is very low voltage power supply, which is regulated, and a current measuring instrument. So, all the experiments that you carry with the electronic devices refer to these kinds of power supplies and the current measuring devices. So, here what is more important is to understand the application of the device, that is the FET, its function and its characteristics.